Welcome everyone. Hope everyone's doing great today. Going to take a little time today to talk about big data tools and kind of what to do after you've gone to that first introductory session on big data. You've learned about the basic infrastructure. You know what it's comprised of, the head nodes, the data nodes. You've been able to, in some demo, load some kind of data, whether it be just a file or Hive, and maybe even use some pig. So now you're to the point of, okay, well, what do I do with it? I've got the data out there. What kind of tools are there to use, and what do I want to do with that data? And that's kind of where this presentation kind of fits in your career life cycle when it comes to big data. So a little bit about me. I'm Josh Ludeman. I'm a business intelligence consultant here at PragmaticWorks. I've been working at PragmaticWorks for coming up on a year soon, and just working on a multitude of business intelligence projects and big data projects in some of our offerings in that space. I blog at joshludeman.com. You can also find me on Twitter at joshludeman. Proud father, definitely. Those are my two girls, joys of my life. And also on the side, I am a fashion consultant, so if anybody's looking for anything to help maybe kind of freshen their look, as you can see there, nobody dresses better. So again, what are we going to talk about today? You've got your data, now what do you do with it? You've gone through one of those SQL Saturday sessions, maybe you paid for a training with us at PragmaticWorks or another company, and you're wondering, okay, now what do I do with that data? I learned about what the stack is and how it's shaped, and the different pieces of the overall Hadoop or Apache Hadoop project, and and Hive and Pig, and maybe you learned even how to use Flume and things like that. And now you've got this data, and you understand how to get it there. But now, what are my options to do with it? Why do I want big data? I can put data in there, but what advantages possibly do I get in this sort of space? We're going to go over some of the data mining tools because at this point, data mining is really the major advantage when it comes to big data products. So we're going to go through some of the tools in that space and then show me the data. We're going to take a look at different ways using tools that we all have today on our current desktops and our end users have, that they can actually look at the data within a big data environment. So you've got your data. What size do you have? I mean, what kind of data do you have? It's not just the size, but is it semi-structured data in that maybe it's Word documents? Are you looking at very structured data like CSV files or pipe delimited or some kind of delimited file? What kind of data do you have to work with? And then you want to make a plan. The plan is similar to what you would come up with for a plan when you're trying to come up with your own business intelligence deployment. You're going to come up with a plan before you just decide, I'm going to throw a data warehouse out there. You're obviously going to have the discussions internally, look at the return on investment, look at where you want to angle your project first to get the most value out of it, to obviously sell it to management. But again, just like a business intelligence project, most big data projects that do fail are because of poor planning. Even though it is a new technology and is open source, it doesn't mean we want to fire off the hip with it. We definitely want to have a good plan of what do we want to learn from this data, in a direction that we want to go in with it. And then obviously the making a plan leads you into the next obvious step is, which tool are we going to use? When it comes to big data, there are a lot of tools out there to store data, to look at the data, to alter the data. The different directions that you're going to go, and in that, sources, what's your source, what's your destination, things like that are going to feed into which tools you want to use. And also, once you get into the data mining aspect, that's also going to determine which tools you want to use in that space as well. And do you know what you're doing? As crazy as that statement sounds, in your plan, you're going to also want to include some kind of training. There are so many tools out there in the big data space that you want to make sure you're properly trained on the tool that is best for the job. I find it hard to believe if someone says they're fully trained up and senior on every tool in the big data space, because there's so many. Because it's open source, there are so many options to do the same kind of work. So you're looking at the screen now and you're saying, Josh, why do you have so many questions? You sound like a little, like a toddler. Well, it's because there is the silver bullet mentality in IT, unfortunately. A lot of times with management and hire, where, this is going to solve all our problems, similar to, if you remember, maybe I would say about maybe 5-6 years ago, the IBM commercials that were coming out, and everybody was the cloud, the cloud. No one really ever said in those commercials what the cloud was, but everybody knew they had to go there. Now today, obviously, we fully understand the cloud and understand its benefits, and its its cons, the pros and the cons of the solution, and understand fully that, not every situation is good for the cloud, but there are a lot of good situations more than not so good situations. The same thing goes with big data. There is a mentality with it where we have big data, let's just find out what it can tell me. Well, you don't want to just fire off the hip like that. You want to have a business question, and a lot of times it can be those business questions that you never thought you could solve before, and big data has the ability to help you with those questions. And like I said, big data is the new cloud. Every boss has to have it, but ask them what it is. And a lot of times, if you get a statement from from management that says, well, we just want to go to the, we want to get big data. We just want big data. Well, what do we want to do with it? Well, I don't know, but everybody needs to have, everybody has it. Everybody's going to have it. So we need it too. Those are the kind of discussions that you need to flush out some more when kind of going into a project like this. In requirements gathering. Now, for all of my agile friends in the crowd today, yes, I understand. I just swore in 7 languages right there by saying requirements gathering, because it is more traditionally referred to as a waterfall term. But requirements gathering in this case can even translate to getting the proper user stories. You want to fully understand the problems and the data and the entire issue and environment that you want to put big data into to help you with your problems. Without a full scope of that situation, just like a big data project, it's not going to survive. So you need your plan, your roadmap. You want to know what kind of data you're looking at. Again, getting back to that structured, semi-structured data, I've been told never to use the unstructured data, so I won't use that term. What do you want to learn? Again, what do you want to learn from the data? What kind of, do you want to get some kind of predictive analytics going on? Is it just a large data set that you'd like to aggregate that maybe you're having issues aggregating in other systems? And then the end game, what are you going to do with the data? Are you going to, again, maybe use this to aggregate some kind of data to then feed it in and do some kind of analysis of the data, maybe with R or Azure ML or Azure Machine Learning to get some deeper meaning of the data? Are you going to use it predictively and get some insights into the future and into your business? Those are, you want to have that plan in place, because without a plan, especially at that stage, it's very easy to get off task or go in the wrong direction and waste time and resources. And then when kind of segues into the time and resources, is this a production solution or a POC or proof of concept? That's a very important question when looking at, obviously, just to come up with, obviously you're not going to use the same investment for a POC as you would as a production solution. Whether you're setting it up in HD Insight, if it's a proof of concept, you might want to use a 2-node cluster to keep down costs of the POC, whereas if it's a production solution, you may want to run it with 4 or 6 nodes in the cluster just to make sure that you have plenty of nodes to do all the work and it's getting it done as efficiently as possible. So first question is okay, you said something about data mining before, Josh. What is that? Well, in its most simplest form, it's finding meaning in data. You're looking for not necessarily digging through the particular, each individual piece of data, but you're looking at the overall landscape and trying to find trends or classifications of data and structures within the data so that it can tell you a story. And there's different types of data mining algorithms. There's anomaly detection. Like you would use anomaly detection when trying to create maybe an analysis of your sales to find your classic customer for your marketing department to target. Anomaly detection would help you get rid of those odd, and outliers within your data set. For instance, Pandora probably picks me out very quickly as one of their anomalies because my music selection is slightly odd. I mean, I have some country, some classic country, some jazz, some metal, pop. I mean, it kind of is all over the place. So it definitely, in that kind of analysis, I would definitely be an anomaly and not anything that they would maybe want to look at in a data set for their classic customers. Not necessarily that at all. Association rule learning. I had to put it in parentheses here instead of just saying it because most people know exactly what it is. If you say market basket analysis, I would imagine just about everyone here at some point has gone out and shopped on Amazon or even like Barnes & Noble's website or any kind of retail website has most of them have some kind of association rule learning or market basket analysis in effect where you go and you add a certain book to your cart to purchase. Association rule learning is what comes in at that point and says, other people who bought this book, like this one as well, or the recommendations that you would occasionally get from Amazon about different items you might be interested in based off of previous purchases and even reviews of those purchases then come into play. Also, it's used, there's clustering and classification, which is grouping people by obvious characteristics or even grouping them together based off of similar trajectories of certain pieces of data. There's regression analysis and then also summarization. And specifically with regression, you're trying to fit an equation to a data set so that basically you can find the y equals x plus 2 for a certain population. And then summarization, I think, is basically what we're all, kind of familiar with in just basic aggregation. So what kind of tools can you use in this space for data mining? Now, as you can imagine, there's a multitude of tools. For instance, there's analysis services, which gives you, not a lot of people are aware of that, but in your analysis services installation, specifically enterprise, you have the ability to set up data mining models within your analysis services instance to actually do some of these basic analysis, like maybe some decision trees, neural network, naive Bayes. Different algorithms are available out there in analysis services. Mahou is one of the pieces of the Apache Hadoop ecosystem or environment. That is out there as well. There's also some great examples. Specifically, I know Hortonworks does one where you can actually set up movie ratings and kind of do a similar thing to what Netflix does, where it recommends movies to you based off of ratings that you've done of certain types of movies and ratings that other people have done of movies that you have rated, combines those together to bring you movies you've never watched that you might like because other people who thought the same thing about certain movies that you liked also liked these movies that you've never seen. I mean, that's one of the many analyses that are out there. You can also set Mahout up to do one-offs or streaming analysis. The thing with Mahout right now, they're heavily leveraged in MapReduce, which some of the newer versions of Hadoop are moving away from. So Mahout is kind of in catch-up mode right now, trying to catch up in that area, but they are moving forward and coming up fast. R is a statistical language. If you've taken college statistics in the, I want to say maybe 10 to 15 years, maybe even longer. R has been around a long time, but it was even used in some universities, and most likely to this day still, for just computer-based analysis and plotting of data. And we'll actually go over a demo in R just to kind of go and show you a little bit about what that specific tool has available to you. And then there's others out in the market. Obviously, SAS is a heavy player in the market with their Enterprise Miner product. IBM has their SPSS modeler. Oracle has their data mining, and then there's also RapidMiner. But recently, within the last couple of months, Microsoft has come out with a piece in Azure called Azure ML, or Azure Machine Learning. Now, it's still in preview, but it is a public preview that you can get in on. And it's actually a very exciting product, and we'll actually go over that as well. So specifically with Azure ML, what do you get? Well, you get a full data mining set of tools. So you can do regression, classification, you can take raw data and do some basic transformations with it and things like that to prepare it for analysis. And then the nice thing, since it's Azure, you're not paying for hardware to have and kind of having that basic recurring cost for maybe more hardware than what you need. You're only paying for the processing time of your model. So the nice thing is with that too is if you're trying a couple ideas about different models you'd like to throw at, and use with your data, you're only going to pay for the processing time of those models. Now, you can create, just about as many models as you could think of and not get billed for them sitting out there until they start running. Now, again, this is still in preview. That is kind of one of the downfalls for guys like me who are excited about this product at this point. I mean, since it's still in preview, I would use it and find ways it can help your organization and your applications. But at this point, I wouldn't necessarily hedge your business on it because, again, it's still in preview, and technically Microsoft can take it back, but I highly doubt it. It's actually a very exciting product. So it's going to come with your basics canned algorithms in the statistical and forecasting or predictive analytics spaces, to the point that you can even run your own R scripts. So you can write your own scripts in R, which we'll go over in a few minutes as well, and actually put those in to one of the algorithms that you're running in Azure ML. And then it's designed to run within your own applications. So once you create your model, you've trained your model, it's to your satisfaction, you can then set it up as a web service and have your company's web applications, however, or any application really, plug into that service and actually send data and pull data from the model. Actually very exciting. So what is R? Because now you've heard me mention that a couple times. Well, it's open source. It does do the statistical calculations that we mentioned before, but it also does graphing, which when we go over that, I'll show you a couple different, well actually one specific graph as part of the demo where you can actually create the graph and even in the script write a file of that graph in a basic PNG file and store that to put in maybe other documents or even use that PNG file in an application. It's built on top of C, C++, and Fortran, so I mean as you're reading those languages I think we can all kind of agree that it is a fairly old language, but it is extensible. Similar to PowerShell, you can build additional modules and commands for R within R and just reference them and pull them out of your library. So some of the basic uses of it, you can graph equations with it, plotting your data for identifying patterns. In our example, we'll look at weighting a regressive decision or weighting decision tree analysis in each direction and non-weighted, and kind of look at the variance in those decision trees to see how well our model is. You can use it for basic algebra, for solving equations, just as simply as typing in the equation and it'll return a value, and then you can even plot that value. You can do basic 2 plus 2 if you need to. It can be a calculator. It's very kind of vast in its abilities in that way. And then again, it has that advanced statistical algorithms both inside of it and in additional libraries that you can load to give you the ability to run statistical analysis of your data. So some of the high points of the R language syntax: you can reference your values of an array through index combos or column index combos. Your basic missing value check, so that you can make sure you're, see if a value is null or is empty. Just basic is NA. And casting variables is as numeric. So you can see the syntax is actually very simple, very logical, human, almost English in a way. Similar to, again, the simplicity of PowerShell, get command. Very simple commands, not a lot of crazy syntax, C in, C out, stuff like that, but just regular speak, or regular, I don't even really know what words, what to call it. Just basic English. So let's go ahead and take a look at Azure ML and R. And for that demo, what we'll actually do is we'll actually analyze the same data set, just through one through R and one through Azure ML. So the data set we're going to use is, we're going to kind of use the basic same analysis or same example. If you're familiar with analysis services trainings that have been done before, in basic data mining example would be to look at the vTarget mail view to identify people who would be bike buyers in the AdventureWorks data set. So what we're going to do today is we're going to go ahead and we're going to load that data set in our R script. Pardon me for a second. There. Forgot to move it from my folder. There we go. So now we've loaded the variable target mail by reading it from the CSV file. Now there's a couple different packages that we're going to need to install, one of which is ML Bench for some of our statistical algorithms, and then the party one as well for some of our graphical uses later in the demo. So now we're going to go ahead and take that target mail and we're going to split it in a way because we're going to set our sample size at 75% of our records so that we can use that to create our model and then analyze the other 25% and then compare the results to see how we did. And what we're going to do here is a basic C-tree analysis without using any weights. And we're going to do the prediction and then the probability within that. We're also going to create separate list of variables with the weighting of 1 to 10. Again, same calculations, just weighted. And then we're going to do the same calculation again, just weighted in the other direction, 10 to 1. Now you remember, actually, I referenced how we could store any kind of graphing into a file. Now when we're doing this in RStudio, which is the more popular development environment for R, we have a space over here where it'll graph our plots. But for us, we want to create a file just to see, some of the advantages of R. We're going to create a file where we're then going to put our plots on, and save it so that we can use it in maybe a PowerPoint, or maybe we want to use it somewhere else in an application or something, but just put it in a file so we have it so that when we close our studio we can still show our results. Now we're going to look at our ROC curves to look for the accuracy of our model, because now we've done all the work for the model up here, but now we want to see how good of a job we did. So we're going to add the package for ROC curves. And we're going to go in here and create our prediction object from the probabilities to, just like it says in the note, to determine if our model is any good. Because at this point, this is going to tell us, okay, in your sample, this is how we learned about, kind of what were some of our indicators within our data set. And then this is going to look at the other 25% of the records where we applied that model, that calculation, to our data set and find out, okay, when we applied that equation, we came up with this as a probable, whether or not they would be a bike buyer, but what we, and then this is what the actual value was of whether or not they were a bike buyer. What this helps us with is looking at our model and saying, okay, this is where we need to tune it, or, oh, this is perfect, we don't want to mess with it. But it'll help us in that analysis, kind of looking at how good of a job we did with our model. And this is going to be a variable that's actually going to store the performance object for our ROC curve. So just looking at false positives and true positives, things like that, to find out how far off we were. And then here we go, we'll start plotting. We're going to put a legend on here. And then we're going to do the same steps for our 1 to 10 and our 10 to 1. All right. So now we would have a file name on the desktop with that graph. That we can actually display. Let me see something here. Well, I apologize. Apparently my graphing isn't working. It did create the file, but did not put the plots in. I'll have to diagnose that. And at the end of this, I'll be doing a blog post that I'll put out later this evening and tweet about, and where I'll figure out what exactly went wrong with this specific demo. I can tell you it worked actually earlier, so I'm not sure what happened with that. But again, there's our file there for our graph. So now let's take a look at Azure ML. So Azure ML is very handy because we can actually do some of the basic same analysis that we did with Azure ML, or that we did with R, and do it in Azure ML. The first thing we want to do, though, is we want to go out and, in our case for this demo, and just for simplicity, you can reference a data set within blob storage, but for our demo, we're going to load our data set directly into Azure ML. So you click the plus button here. It operates similar to the Azure Management Portal, in that the UI experience is a lot of the same plus signs and things like that. We're going to go ahead and add the data set from a local file. We're going to browse. We're going to go to our desktop here, and there's our target mail data set. We're going to change the name of the data set just because this is what's going to show up in the listing when we begin to work with the environment. I just want to make sure if this has a header, which it does. So now it's uploading our data set directly to Azure. Again, this will create a blob storage account, or it'll actually load it in blob for us in one of our default storage accounts on your Azure account, just to store the data in Azure for the analysis. And we're going to create a new new experiment, new work within our workspace. And the first thing I would hope you see when you open this up, especially if you have experience with SSIS, you'll notice this looks eerily similar. It's a very graphical development environment for you to work with, which for me, as a business intelligence developer, I don't know about you, but for me this is very comfortable. So what we're going to do is we're going to drag this out here, our target mail. We're going to create a new experiment. With this experiment, we're going to change the name here because that's not very telling. And we're going to call this the bike buyer. And then what we're going to want to do is, because we want to do the split at this point, because we want to create our training and our testing. So we're going to what's very nice is with Azure ML, gives you the ability right here to search for different items. So we're just going to type in split, and right there you go. Right there is our split. We're going to drag that out on the design surface, and we're going to connect it right there. Now, as you notice, with the split being blue outlined, over here it gives us some options for how we want to split the rows. The default split, as you can see, is set to 50%. We're going to want to change that, though. We're going to change it to 70%, so we can do a 70 to 30. And then for the rest of these, it's not necessary that we need to change any of it, so we'll go ahead and leave that alone. For this specific demo, we're going to use a two-class boosted decision tree model. So back here, we're going to delete split out so we can see all of our options. And we're going to go into machine learning and initialize model, because we want to initialize the model. And then what we're going to do we've got that out there to train our model. And we're going to select our train model right here. And we're going to put that one in there, and we're going to put our 70% into there. The reason being, we want to go ahead and training. We're going to use the two-class boosted decision tree to help train our initial data set and create the equation. Now that we're in train model, we need to tell it which item or which column we would like to predict. And then we want to go in here and select bike buyer. Now what we're going to do is we're going to go ahead and run our model real quick. It'll just run for a little bit, but it also helps with the metadata around columns and things like that to work their way down through. Now that that's completed running, we're going to go ahead and score our model. So we're going to go ahead and put this out here to score the model, and we're going to take and add into the second input our 30%, so our subset of records that we want to do our analysis on, and our train model into the other input to feed in the calculation that we want to use. And then let's go ahead and run that, and we'll process down through into the next step to, again, update our metadata and feed it down through to the score model end. Now we've went ahead and scored it, so let's look at evaluating our model so we can see how well we did. So we go ahead and put evaluate model down here. We won't worry about the second input for evaluate model, but we'll feed in our score into the evaluate model into the experiment so that we can, and then now we're going to run it one more time so we can actually take a look at how the model did. And then there's a couple different ways we can kind of look at what our results are, but what we're going to do is we're going to visualize. So now we can actually see it's the same ROC curve that we were looking at before to show how well our model did. Now a ROC curve, if you're familiar with it, should look similar to this with a high initial vertical climb and then level off. So actually our model is doing really well. And then again here it gives our values for true positives, false negatives, our basic accuracy, which obviously we want higher than 79%, but for our first stab at it isn't bad at all. But we may want to look at maybe some kind of weighting or something like that to kind of give us a better model or more accurate model. So again, this is just one way you can use Azure ML in your environment, but then to reference it from another application, once you're comfortable with the model, you would go through the steps to publish the web service, and then there's .NET libraries that you would use in a web application or any application for that matter to actually connect to the web service and begin to feed it data and receive the output into your application. Maybe you want to set up a basic market basket analysis within your application. This would give you that ability to do that within your own environment. Well, that's not helpful. Let's go back. So I have data. Now what? Now we've analyzed it. We've used R. We've used Azure ML, and the next step would be is how you would integrate that data into your current ecosystem. Now, granted, I encourage you to integrate that data into your current, whether it's your business intelligence environment or your applications. Do not silo the data. As we know in life, when you silo intelligence or silo data from situations, it actually hinders trying to get a full view of situations, and businesses in the same way. And then after you integrate it, you obviously want some tools to show it. Now, depending on how you integrate it, depends on, will kind of help determine how you're going to show it. But again, with integrating it, it all comes back to the plan. Which way do you need to send your data? For your big data project, are you just receiving the data in to the big data application and maybe just generating some analysis, but not really working it in with your data warehouse, which again I frown upon. I'm a full believer in the more you know, the better you can react as a company or as an organization. Direction does determine the tool. You're not necessarily going to use SSIS to load data into Hive. You may want to use it to export to a flat file and pull that into your Hadoop cluster, but I wouldn't necessarily go straight in, because again, SSIS is set up for row by row when it comes to interfacing with Hive specifically. So it's very resource intensive, not necessarily the best course of action. And again, I can't say this enough, resist the urge to keep the data separate. As much as they feel so different in that, obviously most Hadoop environments are running in Linux or even in Azure. It feels weird to integrate that maybe with your Microsoft data warehouse, but resist that urge. There are ways to integrate the data. There are best practices around integrating the data, so don't keep them separate. You want to help enable your organization to show off, and to be able to utilize that data with data sets that you already have. So I need to show off my data. What are my presentation options? Well, I mean, just like your data warehouse, there's options for developing home-baked web delivery of your data. Reporting services could be an option depending on what you're doing. But you also have self-service BI with Excel and specifically Power Query. Power Query gives you the option to actually connect into either an HD Insight cluster that's running in Azure, or even an on-site Hadoop cluster connecting to Hive to actually pull data out. And the nice thing is when you use Power Query, you are actually navigating the tables within Hive, or within you're navigating the tables and the directories within your cluster, and then being able to pull out either that data or the actual data within the files. And you get that option when you're navigating in Power Query. So I know I kind of ran a little bit quick, and I definitely believe there's a lot of questions, especially when you kind of glaze over data mining. That opens up a lot of avenues. I probably won't have time to answer everyone's questions, but I definitely wanted to leave at least 15 minutes to do it. But to kind of wrap it in a box, yes, big data is new and it is really cool. A lot of the problems that it's already out there solving for organizations is very interesting, very exciting. There's companies out there actually using machine learning algorithms kind of set up in conjunction with each other, where it's actually reading documents and understanding the relevance of, words and numbers versus other words and numbers in documents. To be able to tell a page number in a maybe 5 to 10 page Word document from a part number, and understand the relevance of that and how it relates by again tuning that equation when you're looking at some kind of regressive analysis. You need a plan to be successful. If I haven't said that enough, I apologize. If I've said it enough and you're annoyed, good, you'll never forget it. You need some kind of plan. Just like your traditional data warehouse project, you need a plan for this to be successful. If you don't have a plan, it almost is guaranteed to fail. And again, just like I said here towards the end a couple slides ago, the tech is different. Don't silo it though. When you silo the data from each other because the tech is different, you're setting your organization up for failure by not giving them a full view of the data that's available. And again, just because the tech is different, getting the data out isn't as hard as you think. Power Query and the other we'll call them power tools, make it very easy to actually get in there, connect with your data, and show it. Some of the resources that I found and have been helpful to me, if you're looking for resources to help you understand Azure's deployment of Hadoop, called HD Insight, Microsoft Virtual Academy has some great courses, on understanding Hadoop and the ecosystem and kind of how that relates to Azure. Also, some coursework that can be done through Microsoft Virtual Academy on HD Insight itself and how to do deployments and how it works. It's a great tool and it's free. All you need is a Microsoft account to sign in, which is also free. So I really recommend you to take advantage of that. Download the sandbox. If you're familiar with Hortonworks is a company that has their own distribution of Hadoop since it's open source, and they actually have a distribution that will run on Windows Server. But the sandbox is a standalone virtual machine that runs Linux, but comes chock full of all kinds of goodies like tutorials, how-tos, in a more user-friendly web environment to interact with Hadoop. On your own, that you can run in a VM, maybe just give it 4 gigs of RAM, and it'll run the website, and that you can interact with the cluster, and it's just a single node cluster that you can run on a laptop. And it just helps you kind of get your hands on the technology using Pig and Hive, and you can even use the command line by using the console of the VM as well, but it's a very handy tool. And if you're familiar with MOOCs, MOOCs are a lot of times websites or even divisions of universities that actually offer college-level courses for free. The only thing you don't get out of those courses is the actual credit hours towards a degree, but it's free. So, for instance, there's, I believe on Coursera.org, which I'll put out in the chat right now. Coursera.org has a, I don't have that anymore. Liz, I'm going to put it into chat to you. If you could put it out to the group, please. The Coursera has a course that they offer on Statistics 101 that's actually a Stanford course, and it's given by Stanford teaching assistants, and it's actually a great course. I recommend. I've actually taken pieces of it just because of my schedule and things like that. I haven't been able to fully finish the course again as a refresher, but it's actually a very good course, very comprehensive. And now that we're towards the end, Liz, could we go through some of the questions anybody has? Here's my information again. If you'd like to take a screenshot so you have it of any email, my email address, Twitter. I'm open for any questions, and thank you for your time today.
The only question is someone wanted to see slide 11 again.
Slide 11. Okay. Let's see.
But if you guys do have any questions, go ahead and put them in the question box, please.
This is the one I have marked as slide 11. It may be something else they're looking for.